Again, good morning, everyone. Can you hear me?
Good morning. Yes.
Okay. So let's get back to this module on excuse me, sensor system and application. So you recall we have finished two chapters. One was in introduction to sensors and actuators in IoT itself, and the second one was specifically was on microcontrollers. Okay, the sensors, the actuators, and the microcontrollers. So these are things that we have finished also in the in the lab. Okay, so with respect to lab materials, just a brief recap. Those who were in the lab that is last week, we have completed our first lab on Arduino programming, where we have worked with a LED and have written our first program on Arduino and executing it on an Arduino board. Okay, all the others, those who are not present in the lab, make sure you're present and you catch up with respect to the lab. It is important because as we proceed, I will increase the complexity in the lab as well. Okay, so I think your assignment too also, the deadline was last week. I still need to have a look at it. We'll proceed now with the lecture materials. So your third chapter for this module is on architectures and standards. Hopefully we'll complete the architecture part this week, and then next week we complete the standard parts in order to complete the chapter on architectures and standard. Obviously, it is related to IoT architectures, to sensor system architectures, and standards. Okay, so let me share my screen, entire screen. Okay, so should appear soon. Let me start the PowerPoint as well. Okay, so tell me whether you're able to see the slide.
Yes.
Okay, so it is about architectures and standard, as I have told you, our chapter 3 for this module. Okay, so seems someone wants to join before we start. Okay, so we'll start our chapter 3, architectures and standards. So just to tell you that I think, I don't know whether this graphic I have already shown you in the introductory lecture. So the landscape for IoT, for sensor system is very, very congested in all domains, whether it is healthcare, whether it is home, vehicles, in enterprises, in industries, in all sectors, we are deploying IoT systems. So this is why it has become so congested, why so many companies are already investing a lot on IoT in order to capture useful data and then to derive insight to perform data analytics in order to derive insight into their data. So on the top, you see here the different verticals, as we call it, the different applications: personal, your health, personal application, fitness, things like this; home, vehicles, enterprises, industrial internet, Okay, so these are the different application verticals. Then platforms also, today we are going to talk about the different types of platform. Some platform are with respect to the software, security, connectivity, analytics is closely related to the IoT. And then the different building blocks, the hardware, those providing the sensors, the infrastructure. Today mainly we are going to discuss about the infrastructure, connectivity solutions, short distance communication, long distance communication. Okay, so all these are the necessary building blocks for the IoT. So this diagram is just not for you to read, but just to show to you that so many companies are already operating in this area. So this is the why you are having to study this module. Okay, so we have different bodies, different companies that are involved in this area, like standard companies. You have the ETSI, so European Telecommunication Standard Institution. They are providing like necessary standards for companies to operate in this area. I know whether you are aware, when it comes to telecommunication, when it comes to such kind of systems, so you need to abide by a proper standard. And you have, for example, IEEE, that here it is IEEE that propose a number of standards that all companies should abide by. You have also the ITU, the International Telecommunication Union, IETF, Internet Engineering Task Force. So just to tell you that all these, we call it standardization organization, they are involved in formalizing, in standardizing IoT as well. So not only standardizing in terms of communication, Wi-Fi, Bluetooth, the different types of communication, but also standardizing the type of architecture that we should be following, the type of communication that we should be having, the kind of data transmission that we should be having. So they try to standardize all those aspects of the IoT. So there is also a war on standards. So everyone wants their a platform, their techniques to become standard. So you know, when your technique becomes standard, you become very popular, and everyone starts using your own. So like you have Apple have got something called HomeKit. You have Google with its Nest and Firebase. You have Google again with something OpenThread. Okay, Intel with its Intel IoT platform, IoTVT for short. Samsung also is there, Microsoft with its Microsoft IoT Azure, Cisco IoT, Amazon with its AWS IoT. So I'm going to introduce you to some of these today. So all those big players, big companies, they are in the domain of IoT, and they want their platform to become standard. They want everyone to use their platform. Just to tell you that even in this area, you have lots of companies that want to have a lion's share of the market. Okay, let's start now on the IoT architecture itself. So I will cover here. I think in my introductory lecture, I've already introduced the generic IoT architecture. I will come back to this generic IoT architecture, and then we will see what I have chosen four main providers of IoT for this lecture. You have Amazon, you have Google, you have IBM. So Amazon with its Amazon Web Services, Google with its Google IoT, Cloud IoT. I've chosen Microsoft with its Azure IoT, and then I've chosen IBM with its IBM Watson IoT. So obviously, I will just introduce it to you, the main components and everything. So we are not going to work explicitly on this, but it's good to know that these are the different main platforms that we have in this area, and what are the kind of services that they offer. So this will be my main objective for today's lecture. So let's have a generic discussion about IoT architecture itself. So there are a number of elements that are there in an IoT system. So you have the physical elements themselves, so the devices and the network. So the things, okay, that we are monitoring. These are low capacity devices, the sensors, actuators. We have already covered this. You have the whole part on the infrastructure, mainly for capturing transmission of the data. So you require a particular kind of network. So sensor communicating with sensors, this is one type of communication. But then sensor communicating with a gateway communicating with a cloud platform, So this form part of the infrastructure. Then obviously you have enormous amount of data that is being produced, that are being captured, that needs to be stored. And obviously in IoT system, most of the time, it is a cloud storage that we favor. Okay, we send all the information on a cloud storage. Then you have your user devices, phones, tablets, whatever, embedded devices, okay, all these forms of devices. There is a concept of fog. I think at the end of this module, we have a chapter on fog computing. These are basically high capacity devices in the vicinity of data generation. So fog means it is not cloud. It is something in between the cloud and your sensors. We try to implement something which is closer to the sensor. The cloud is quite far. You need to go through the internet and access the cloud. There's a new concept now where we are implementing some powerful computers within the network itself, that is in the proximity of my sensor, a sensor network. So this is where we got the term fog, a fog computing. We have one complete chapter on it. Don't worry, we'll come back to this. And obviously, clouds, you already know about cloud platform. So cloud is very closely related to IoT, to sensor system, because those sensors, at the end of the day, they need to transmit the data which is stored and used from the cloud. Let's continue. So, okay, since we're talking about IoT architectures, okay, so there are certain requirements for such a type of system, that is sensor systems, IoT systems. So let's see some of those unique requirements that IoT architecture should have. So first of all, they handle extreme hardware and software heterogeneity. Okay, I think I should start getting your opinion on the different aspect here. I already introduced the chapter. Now, see this point. I will put a question to the class. Handle extreme hardware and software heterogeneity. Okay. First of all, we will need to focus on the word heterogeneity. And when we are talking about handle extreme hardware and software heterogeneity, what it means. Let me go to the class. Bavish Muhabir, are you on? Yes, Bavish Muhabir. Hope we don't have problem again with mic. If problem with mic, I hope your keyboard is working. You can type something on chat. Bavish Muhabir, are you on? If not, I will move to, yes. So I will put the questions to you. So you're available on chat. I put the slide again. I hope you can see the slide here. So one of the point, we are talking about IoT architecture, and one of the requirements for any IoT architecture, as per the slide here, it says handle extreme hardware and software heterogeneity. I want to understand first, what is this concept of heterogeneity? Then I will ask about extreme hardware and software. But let's see what is your understanding of heterogeneity. Yes, Bavish Muhabir. I encourage you, like, since you have many lectures online, so your keyboard and your mic, as far as possible, get it working. Okay, so your friend Bavish Muhabir is saying that being able to connect at all times. Okay, so this is his idea of heterogeneity. Let me try Daniel Ashley Ling Ying Hong. Are you around? Preferably put your mic on and tell me what you think about this concept of heterogeneity. It is a very important concept actually in all computer systems we can say. So this is why as applied computing student it's important that you are aware of it. Yes, Daniel Ashley.
Yes, I think it's like it has many ways, like it's diverse in many contents.
Okay. Yes, I can more to go toward the explanation of Daniel Ashley than Mohabir. Mohabir said being able to connect at all times. Not necessarily. But when we talk about heterogeneity, everyone, it's more have to do with the variety, with the, like we say that a system is heterogeneous, meaning that it can accommodate different types of what? It depends on what level of heterogeneity you're talking. So when we talk about a heterogeneous system is a system that can accommodate various type of. So if I put the slide again, we are talking about handle extreme hardware and software heterogeneity. So I'll put a question again to the class. Let me see. Let me go down a bit. So Subhati, Irfan Ali. So when we were talking about handle extreme hardware and software heterogeneity, what do you think? What the IoT system should be able to do?
It should be able to adapt to extreme conditions, like to test its capabilities to the extreme level it could be used.
Okay, I'm not getting the complete thing. Let me try. I see Subarat.
Yes.
Yes. So your friend, we understand what is heterogeneity, which is various type of, but here we are talking about, let me put the slide, handle extreme hardware and software heterogeneity. So it's a very important concept in IoT. So tell me, what is your idea of this term?
So the system can run with different kind of hardwares and softwares.
Yeah, so this is basically, we said various type. Yeah, your answer is right. I'm satisfied with this one. So Sibarat is saying that the IoT system should be able to work with various types of hardware. And obviously, when we are talking about various type of hardware, here we are talking about various type of sensors. So whether it is a sensor from Liberium, it is a sensor from a Texas Instrument, it is a sensor, whether it is Arduino, it is Raspberry Pi, it is different kind of board. So your IoT system is able to map the differences between the boards, between the different types of sensors. So this is what is called hardware heterogeneity. Okay, your system is able to work with different types of hardware. Okay, and obviously software heterogeneity, that is, it is not dependent on one type of OS, on one type of software. It can work with different types of software. So if I put the slide again, so when we are saying that in IoT system now, handle extreme hardware and software heterogeneity, what we are saying, such kind of system, previously our system were very opposite of this would be, I'm trying to find the word, opposite of hardware and software heterogeneity. It is single-minded. It works with only one kind of software, one kind of hardware. It is vertical. Okay, so it is not horizontal. It doesn't cut across. So this will be the opposite. So now we are talking about a kind of system that should be able to support all sorts of hardware, all sorts of software. So this is a very important requirement for any IoT system. It's not that an IoT system works with only one kind of sensor. When we try to connect another type of sensor from another provider, from another supplier, it no more works. So this is again the idea of an IoT architecture. So if you're having an IoT architecture, it should be, let me, to the class, whole class, it should be what? When we try to connect another kind of hardware, another kind of software, it should be able to do what? Should be able to work, yes. How you will, if you're a synonym for such kind of system? Yes, to the whole class. If not, I will pinpoint.
Interconnection.
Yeah, so I see Kaviraj Kosai is saying compatible. It should be compatible with different types. Yeah, someone just said something. Say it again.
Interconnection between the different hardware.
Okay. Yeah. You're talking about interconnection. I will use a more appropriate word, and this is the word that I was looking for. That your system is interoperable. It is interoperable with other types of any kind of hardware or software. Okay, let's proceed. So we have a number of requirements. We have discussed a lot on this extreme hardware and software heterogeneity. So now you understand the idea of heterogeneity. And when we talk about hardware heterogeneity, is that it adapts, it is compatible, it can work with different types of hardware. Okay, second point, build a hyperscale, enable low data latency. There are 2 points here. Build a hyperscale, and on the other side, it says enable low data latency. Enable low data latency, I think it is quite easy. Let me have someone in the class to tell me what is enable low data latency. Tosif, Edu?
Yes.
Yes, what is do you think about enable low data latency? What does that mean? I think if you have done some networking, latency, what is latency? Enable low latency.
Should be able to process high volume of data.
Is it about the volume or it is something else? It is something related to what you're saying, but I don't think it is about the volume. Yeah?
The time.
It is more about the time, exactly. Yodish Niranjan, can you help Edu? Yodish Niranjan? Okay, your friend saying delay in transmission. Okay, so more or less what you're saying. And when we're talking about enable low data latency, that is in the IoT system, the IoT architecture should be designed in such a way that it don't take a lot of time for your data to be transmitted from the sensors eventually to the cloud, because the latency should be very low. The time it takes to transfer from the sensor to the cloud should be in minimum. Why do you think it should be minimum? Let me see. Vikesh? Pidana? Vikesh? Why it should be the case? Yeah? Vikesh Pidana? Oh, you're on? Okay, your friend saying rapidly change data. So we're talking about the why of it. Yes, true. Because otherwise your data can become which word we say when we say that the data is no more valid. Your data can become
outdated.
Outdated, exactly. Outdated, a term we use in, I see Edu is saying obsolete. Yes, very good. Stale, obsolete, outdated. So all these are appropriate. Okay, so we have already seen enable low data latency, and we have already also seen why it should enable low data latency. Let's move on to this one. Build for hyperscale. Build for hyperscale. Hussein Ramjan, build for hyperscale. What do you think?
Maybe to improve on when we add demand to the system.
Okay. It is related to what you're saying. That is, when you add demand to the system, your system is still able to work. Let me have another one helping you here. Shaheen Aldin, maybe Shaheen Aldin, yeah. Yeah, so I'm asking on the building hyperscale itself. Well, what does that mean? Building for hyperscale. Let me check what is exact wording. Yeah, build for hyperscale. That is, in IoT system, we should build for hyperscale. What is this idea of building for hyperscale? This is what I want to understand. Yes, Shaheen, what do you think? I see most of you are using chat. Building for hyperscale. Be able to handle large data entry. Is it about data entry? Yes, large. It's about large, exactly, not necessarily related to data entry, but to handle large what? Build for hyperscale. A Budan, Kumar Budan?
Yes,
Building for hyperscale. Your friend saying large data entry. What do you think?
for future expansion.
For future expansion, right? Okay, more or less we are there. Let's move on here. Yeah, build for hyperscale means be built for a large volume. Large volume of what? Not only data, large volume of devices, large volume of users, large volume of data. One of your friend mentioned about data. So this is what is meant by build for hyperscale. We are not talking about 100 to 100 users. We are not talking about 100 to 100 devices. We are talking about millions of devices that should be able to connect through the IoT architecture. So this is what is called for by build for hyperscale. Millions and millions devices connected to the IoT system. So this is what is called. So your architecture should be able to support this, not support after 100 devices, the performance goes down. So this is not built for hyperscale. Okay, so we had good discussion on these 2 points. Let me continue. Be secure by design, support defense in depth. Be secure by design. This is also an interesting point. All seems to be quite interesting points here. Be secure by design. So all of you know about security, but what is this idea of be secure by design? And this idea, most of the idea that I'm discussing with you here, it doesn't apply only to IoT architectures. It applies also to any new types of system that we are deploying, even in enterprises and everything. It should be heterogeneous. It should be having low data latency. And now we are talking about be secure by design. I want to discuss this as well. Even if we are proceeding quite slow, never mind. The discussion is very important. Yes, Davison Pemal, what do you think? I'm asking about be secure by design.
Yes, the IT system must be, the security must be high.
It must be high. Okay, it's about security. It's about security being very good. But when we say by design, be secure by design, I want to understand this. Well, what is this idea of be secure by design? Okay, no problem. Let's try to see if we can have someone helping you. Janushka Badal. Feel free to answer. I'm not expecting any good answer, whatever. What do you think? What is your opinion about secure by design? Yes. What is your opinion, Janushka Badal, about secure by design? I'm not expecting any good answer, but just tell me what do you think, what is your idea? Implement security features. Okay, implement security features, yes, but it is not communicating this by design. Let me try a last one, a Keshav Kalichan. What do you think is by design? Yeah.
Security measures should be implemented at different points in the design itself.
Oh, yeah, very good, very good. So your friend is right here, Kalichan. So he's saying that, see, when we talk about implementing security, when we say secure by design, security should not be an afterthought. Security should not be, you have already implemented your system. Now you're thinking, how are you going to make the system secure? This is wrong. Actually, this is wrong for most systems. For most systems that needs to be highly secure, you cannot implement the system, then later you reflect how you can make the system more secure. Actually, when we say be secure by design, is that when you're thinking about the system itself, you think about how to make it secure. That is when you're designing the system itself, you embed security there. Security should not be something later that you decide about it. This is what is called security by design, or be secure by design. It should not be as an afterthought that later we think how to implement security. It should be when we are thinking about our system itself, when we are deciding about how we are going to structure our system, we think about security at this level. That is at the level of conceptualization itself. We implement security, and we don't wait at a later stage in our development. So this is an important. I'm introducing to you to very important concept that is not only related to my module. It is related to all types of systems that you're going to be exposed to, that you're going to develop in your future career. So recall those points very well. Okay, let me continue. Support defects in depth means high level of security. Let me continue. Low barriers to entry. Again, I'm having to stop here as well, since it is something very important again. So since there are many things are very important here, I'm thinking about a question that I should put either in your test or an exam related to this. Okay, so low barriers to entry. Again, very important thing when we say about low barriers to entry. Maybe more difficult for you. Malia, Zuha, Chatu, yeah. What do you think about low barrier to entry? Yeah, lower barriers to entry. Maybe more challenging this one. Yes, you also by chat. What do you think about this? Low barriers to entry. Reflect on it. I'll check with Niviti Lawa. I'll prefer that you use your mic if it is available, otherwise chat. Yes, Chatu? Anything? Low barrier to entry? Niviti saying facing obstacles. Chatu is saying access to data should be done based on different privileges. No, it doesn't concern security actually. Facing obstacles also, no, it is not communicating the idea low barriers to entry. Anyone in the class? Anyone in the class? Try.
Maybe the time to deploy the system should be at its minimum as well. This can address the issue of the data latency as well.
You're very close. Yeah, Keshav is Kalichan is very close to the idea of low barrier to entry. He's saying that it should be done very fast, and we should be able to transmit the data very easily. It is very close to this. Anyone wants to try? Joseph Adel Rose?
Should be easily maintainable, like lowest downtime possible, like least amount of downtime.
Okay, so you're talking about downtime, easily maintainable. Okay, it is related to both what you're saying. Let me explain in detail here. Yeah, low barriers to entry basically. See, you are setting up an IoT architecture. Now people should be able to connect their sensors to your architecture, so as you can receive it on the cloud. Like Microsoft is providing an IoT service, so as people can connect their sensors, get their data on the cloud, and use the data, perform analytics on the data and everything. When we talk about lower barriers to entry, means it should not be difficult for anyone, even with a low competence, low technical competence. They should be able to easily connect and transmit data. This is what is called lower barrier to entry. If it requires high level of competence, it requires lots of configuration. We need to set path, we need to configure, we need to be aware how to configure our network or whatever. Then it becomes like a barrier to entry. Then it becomes like you should be an expert. A novice user cannot connect directly. So when we talk about lower barriers to entry, this is what we are trying to communicate, that it should be very easy to deploy. It should not be something that we need to be an expert to be able to do. This is what is called lower barrier to entry. If something has high barrier to entry, then you need a lot of training, a lot of competence. You need to be an engineer to be able to use it. Here we are talking about even a novice user plug and play facility very easily we are able to connect our sensors and we are able to transmit. I'm not talking about developing the infrastructure. I'm talking about using the infrastructure. Okay, let's continue. We had a number of good discussion here. So deliver telemetry. Telemetry means remote measurements, information, collection of data at remote points, and the automatic transmission to receiving equipment. It should not be that someone is doing it manually. Automatically, data is being read somewhere, transmitted, okay, and notification that are meaningful even at like extreme scale. Extreme scale, I think now you understand what I mean by extreme scale. That is, even if we have millions of devices, we are able still to collect the data and transmit the data. Okay, last point, but very important point. Yeah, there is a concept of, I don't know whether if you study data analytics, you will encounter something called hot path analysis and cold path analysis. Have a look at the last point. Maybe I will have a discussion on this one as well. Provide hot path analysis or cold path analysis. I want to differentiate between those two. I want to understand what is when something when we're talking about hot path analysis, what kind of analysis it is. When I'm talking about cold path analysis, what kind of analysis it is. We have both in IoT system. Most often, most probably we have hot path, but we do have cold path as well. I want to understand like the difference, the meaning of those two terms. It is in data science, in data analytics, we use it a lot. Anyway, in IoT as well, because we are collecting large volume of data and everything that needs to be analyzed. So it is relevant to us as well. Okay, I've given you some time. Now let's see if I can get Jean-Lévy, Yannick. What do you think?
Yes. So
yeah.
I think it refers to the streaming of data workload.
It is very related to the streaming of data. So when it is hot path, what kind of streaming of data that we have?
Instant data transmission. The latency is
the latency should be very low, or it can be high.
High. Sorry, very low. Sorry.
Very low, because latency means time taken. So if you're telling high, means it takes a lot of time. If it is low latency, it takes less time. Yeah, you're right. Your friend is right here. Your friend is saying that when we talk about hot path analysis, meaning that the time the data takes from the time we are taking the measurement and it reaches the cloud. So this should be very low, and the analysis that follow should be very fast. Otherwise, we lose the meaning of the data. Otherwise, the decision that we will take based on this information will be wrong. Otherwise, whatever analysis that we are doing will be earlier. What your friend mentioned about obsolete, about not up to date. I've said it is stale. So this is what will happen if for a hot path analysis we have lots of delay and we are not able to perform. There's a word that we use when it is done very fast. Which word we use? The whole class can tell me.
Real time.
It's done in
real time.
Exactly, it is done in real time. So when we talk about hot path, it is closer to real time. Okay, closer to real time. I think one of your friends earlier mentioned a word instantaneous. It is instantaneous. It is like instantly it happened, quickly, immediately it happened. So this is the idea of hot path. Okay, when something is hot path, you are configuring, you are planning, you are implementing it as hot path, meaning that latency should be very low. It should be very fast. It should be near real time. Okay, so now I don't have to explain cold path. You already know what is cold path. If hot path is this, cold path obviously is slightly the opposite. That is, can tolerate greater latency. That is, there is no so much restriction with respect to the time. Even if I get the data after, I don't know, it depends on the situation. Even if I get it after, I don't know, 5 minutes, 30 minutes, the data is still valid. I can still analyze it, I can still use it. Okay, so this is what is called cold path. For cold path streaming, that is, streaming means the transmission, collections, transmission of the information, and eventually the analysis of the information can be delayed. It is not that this one should be done in real time. So when you're implementing an IoT system, it is important for you to know that is it that it needs to be hot path, or it can be cold path. Okay, so this is a decision you will have to make. So you see, we had a lot of discussion on this slide. I think we have spent nearly 20 to 30 minutes only on this on this slide, which is we had very good discussion on it, but it is very important. All those requirements are very important. Okay, let me proceed now. We had good discussion.